Okay, can folks remote see my share screen?
Yes.
Yes. Okay, great. So so now everything is being streamed, and we're going to continue today over sort of our crash course over Python over Jupyter Notebook. So for folks who haven't got to this page yet, please do so. You can go to the directory where you have git pulled the lectures and run Jupyter Notebook command, and you should be seeing, let me just share my screen again. So if I were going to share my entire desktop, this is where you get to the screen I'm at. So if you go back here, you run it in a browser in the directory where you are. For example, in this particular case, I'm in the directory where I have lecture 3, and then I just run Jupyter Notebook, and it will open a browser that looks like this. And this is where you click on the basic Python 2. And that's where we're going to be for the lecture today. So we're going to talk about types and some operations, recursion, and then there's going to be 10 to 15 minutes of group work. Okay. Before I go into it, there is a first reminder that our first homework is due this Friday. So you should get started now because it contains multiple small questions, as I mentioned before, to succeed in this class, or also to reduce stress. One way to deal with the homework is to divide the homework question into small ones and try to solve one at a time and divide it across multiple days. So the first homework is due on Friday at midnight, but I recommend you to get it done sooner than the midnight Friday so you can enjoy the weekend. Okay, any questions? Okay, if there's no questions, let's get to it. So today we're going to go talk a bit more over data type and operations. And then the first thing we're going to do, if you look at this thing, that today's lecture is really a subset of the complete documentation of standard types operation, which is in this particular page. This is a slightly longer article coming from the standard Python documentation that talks about a superset of what we're going to cover today. So the first thing we're going to do is talking about Boolean variables. So Boolean values are either true or false. And for example, in the first example, I'm going to define a variable called my true variable, and it's Boolean value, so it's true. And then the second line is I'm actually trying to print this. And then I set another variable, which is my false variable, which has a value of false, and I print it again. So if I execute by doing Shift Enter, you're going to see that it's just going to print the Boolean value of those variables. So the true and false are essentially reserved keywords. In the capital form, they correspond to the values of those Boolean variables. And then you can actually do sort of logic operations between those. So what did I mean? If I have true and true, the result is true, right? If it's true and false, what's the result? False. If it's true or false, what's the result? Perfect. So here is just simple operations here. We're just going to do true or false. That's of course either true or false, the answer is true. True and false, the answer is false. If I take the negation, in this case, not false, would you excuse me? I'm actually talking over you guys. Sorry. If I'm doing not true, it's going to be false. And if it's not false, then it's true. So this is fairly straightforward for Boolean operations. You can do the standard and or negation operations. Now, there's also comparison where we can actually compare entities you have things like less. In this case, it means strictly less, and less equal by definition, strictly greater, greater or equal. The difference is that the double equal sign in Python means equal, and factorial or equal sign is not equal. And then we're not going to go into object identity or negation of object identity. We're going to save that for later. So if I do give two number, in this case, two integer, I can return essentially a Boolean result if I compare them. So if I were going to do 1 less than 2, what's going to be the result? True. What about 1 less equal to 1? True, right? So 14 equal to 14? True. And 14 not equal to 14? False. Okay. So now the next thing with this equality sign is, and also feel free to stop me if you have questions. We have a lot of ground to cover, so I'm going into a pretty fast speed. So if you want me to slow down, just raise your hand and say, okay, wait a minute, what can we do the following? So the next thing you can do is you can do comparison between numbers, but you can also do comparison between strings. So in this particular case, I'm asking the question, my text equal to my text. What is the result going to be? True. Now, if I put a space here, let's try it. Exactly. So yes.
So that's different than in like Java where you have to use that equals.
So yeah, so you have to be a little bit careful that, if you know some other programming language, there's a minor textual thing between different programming languages. For example, in Python, we have string, but we don't have character like char, char, right? Okay, all right. So yeah, so in this particular case, I inserted an empty space, and now those strings are no longer equal. So this is sometimes you might make this kind of mistakes, but next thing is obvious, right? If I compare two different strings, what's the result going to be? False. Now, you can also use this to do lexicographical comparisons. So is A bigger than B? So this is saying that in terms of ordering, is A ahead of B? The answer is no, but of course, if A is smaller than B, true, right? Because A is ahead of B. Let's make it a little bit more fancy. What about the string AA versus ABA? Is AA preceding ABA? True, right? Of course, what about AAA versus AA? False. So let's just correct it, of course. What about this one? True, right? Because what it does actually when you do this comparison is actually compare each of the character one by one. So if I were going to compare the ordering between the string AA and AAB, I'm going to compare the first against the first. Okay, they're equal. Let's move on to the second one. A is equal to B. They're equal. Let's move to the third one. The third one, when there's nothing, it compared to B, it's smaller. So that's how you order them. So that's sort of how internally it's trying to do this comparison. Okay. So now we know we can do Boolean operations. We can do comparisons. The next thing we're going to move on to is talk about data types. So there are 3 built-in numerical data types in Python. And then this is the first place where you want to pay attention compared to some other languages, is that Python support integer, float, and complex numbers. However, its integer does not have sort of a fixed bit. And then this is interesting because you can actually compute arbitrary large integers. In this particular case, if I take 2 to the power of 200, if you run it over some other programming language, most of them is going to run out of memory, right? It's going to have overflow. So, but in this particular case, it's actually going to return what the answer is going to be, okay? So this is a very special type for Python because it deals with arbitrary large integers where most of other language does not. So most other languages will incur an overflowing thing. However, later on, when we look at NumPy library, that if you're using NumPy library, it does put an upper bound, I think it's int 64 when you are using NumPy library within Python. So there is what's called building data types, and then there's the data types that comes with some of those packages. Okay. Now, of course, because we're dealing with integers, you can talk about positive, negative, or zero integers. The next thing that we have to be pay attention to is a float data type, right? In order to represent number, say 1/3, is actually represented as 0.333 and with many, many, many digits, okay? And then because of this, what appear to be sort of equality operation in pure mathematics may not be that obvious when you're doing Python operations. For example, if I'm going to ask whether 0.1 plus 0.1 plus 0.1 equal to 0.3, what do you think the result's going to be? I hear something say yes. The answer is false. The reason why is actually, if you look into it, if I actually look at, what is 1/10, it appeared to display, oh, it's 0.1, but in reality, it's something stored like 0.1 with a lot of digits afterwards, which may or may not be all zeros, okay? So in a way that what you are showing here as output is a truncation of what the computer is actually representing. So what you should remember is that you should not compare two floating number with the equality operator, right? And then this might be one of those bugs you might encounter where later on when we talk about for loops or while loops, when you have sort of, or with recursion, if you have a termination criteria, you say, I terminate whenever my A is equal to B. If they are both floating number, that equality may not ever be met. So you are in this kind of infinite loop or infinite recursion. Okay, so how do we get around to it? Okay, to get around to it, okay, so this is exactly the same thing as before, right? I have a variable A, I have a variable B. A is 3 copies of 0.1 and B is 0.3. And I have a condition A equal to B, it's going to return false. Well, sometimes it's going to return true when you get lucky, but sometimes it's going to return false. So you should not rely on this. The reason why in line 26, I want to give that example, is that sometimes those conditions are really hidden because your actual value is represented by a variable and you just compare the variable. So you have to be aware what if those variables are actually float type. So instead of doing sort of equality, what you want to do is you kind of allow a little bit tolerance. In this particular case, remember A is 3 copy 0.1 and B is 0.3. So what I'm going to do is to say, well, if A is smaller than B plus a very, very tiny number and is bigger than B minus a very, very tiny number. So what I'm doing is I'm just saying A and B are very close up to my tolerance level. Then of course, in this case, it's going to return true, right? Because underneath it, when the computer is representing A, which is 3 copy of 0.1 versus B, which is 0.3, they are very close to each other up to this particular tolerance level that I'm giving to you. Because if my 0.1 is represented with many, many zeros, and then there's like non-zero digits, then if I'm just looking at whether those 2 numbers are close to each other, you're going to return the type of comparison result you want. Now, of course, this is sort of the naive code you can write from scratch on line 27. But there's also a built-in function you can use, which is called isClose. So in order to do that, you need to import the package called math package. And once you import the package, math package, you can call this function, which is the package name dot this pre-built function or building function. And then again, you're going to compare AB, and this real underscore TOL is basically the tolerance level. So the same exactly code I have on line 27 is exactly same type of effect, is to say I'm going to see whether those two numbers are close with respect to this tolerance level. So in other way, the absolute value difference between those two is upper bounded by 0.00001. Okay. So if I do that, again, it's going to return true, meaning that those two numbers are really close. I can probably do this by pushing it a little bit further by increasing the tolerance or decreasing the tolerance, actually. In this case, it's still going to return me to true. In fact, I haven't even tried this. Let's see if this is going to happen. I don't know. Let's try it. See, at this particular tolerance level, it's going to return false. That means that, underneath the representation, they are actually start to become different once it's like 10 to the minus 20 kind of digits. Okay. Now, the interesting thing about the package, this is probably one of the few times you start seeing a package, is that there's lots of packages coming with Python that extend the basic functionalities you can have. So in the future, you're going to see more and more packages, so you don't have to kind of code some of those operations from scratch. Yes?
So do we have to import the package for each program, or is it once I import the package on my Anaconda file, it's going to be there forever?
Oh, in the current environment, if you import it once, it's fine. But if you have different programs, you need to import it. Usually you import the package at the very beginning of your Python code. So you know that, there's some standard packages that you typically use, right? I mean, right now, each cell, I'm just showing that, okay, if I want to use this function, I can import this package. But for general readability, of course, this is a personal preference that I like to put packages at the beginning of the program. So I know those packages are standard ones that I'm going to use, okay? Now, you can also to do type. So remember that Python actually support, specifying type, but it's actually implicit. You don't have to. But if I want to annotate type, you can specifically specify the type, right? So in this particular case, I want to say, well, my greeting, like this variable itself, is a string type. So that's how I say it. So I say greeting string hello world, and I print it, and it's going to print hello world. But also, you don't really have to specify the type that Python is going to figure out by itself. So in this case, if I override greeting equal to 3, and Python is like, okay, now I can consider it to be like 3, like integer 3. So in a way that the type is really for readability. If you want to emphasize that this is really a string, I'm going to put the type in there, but it's not required. And also, like, you can define things in this case, again, right? I have a function, greet, and it would take an input variable called name. And again, I want to specify that this particular variable is of a string type. Okay, so in this case, if you look at this particular function, it takes an input that is of a string type, and it just concatenate, and by printing out, by return a string, in this case, there's multiple things happening. I input a string, and this plus symbol is concatenating those two strings together. And that's the output of the function, and I just print this function. So if I were going to execute this function, I'm just going to say, okay, my variable is by calling this function by specifying the input Anna. What is output going to be? Hello, Anna, right? But what about this? Let's say hello, James. What's going to happen? It's going to print out hello, James, just because James is an input to the function, and it returned hello, James, as part of the function operation, and then you print it out. All right, so this is give you, okay, go ahead.
How about you type an integer word or something like that?
Okay, let's try it. type error.
Oh,
Yeah. But if I do this, I'll be fine, right? So the difference is that in this particular case, I'm specified this is going to be a string. Okay, now, oh, by the way, since I'm not monitoring the chat, if you have questions, please just unmute yourself for people who are remote. Of course, now we're going into numerical operations. Those are things like addition, subtraction, multiplication. The ones that we have to be careful here are things like quotient and things like remainder, especially remainder. This is sort of looking at if I divide one number to another, what is the remaining part of this? And surprisingly, you can even do this with a float number, as we can try later. You can do negation, you can do absolute value. Here is the type conversion. You can take something and convert it to integer, convert it to float. And then this is power, take x to the power of y, which is the same as x double star y, okay? So they're pretty straightforward. The only thing that, like I said, the modulo operator is the one you want to pay attention to, which is the remainder of division. So what remains if I take 7 divided by 2? 1, right? What about 7.4? Yeah. So in a sense that this is a little bit beyond your typical integer divisions. Okay, so you have to be a little bit careful. Now, the next thing is, of course, operations like addition. If x equal to 2, y is equal to 3, the third line you want to pay attention to, what this does is to say, I'm going to take the current variable x and y and send that value to my variable x and show what x is. So what is x going to be? 5, right? But now you can also simplify this by doing this plus equal. This plus equal is a shorthand version. I personally is not a big fan of it. It really reduces your code by like 2 characters. But really what it does is does the exactly same thing. X is equal to x plus y, okay? So it's a shorthand representation. And you can also do shorthand representation. In this case, this is say x equal to x minus y. So it's really saying that the left variable is equal to the left variable minus the right variable. Okay, so in this case, this is -1. This one now is division, right? So you take 2 divided by 3. Now the result is going to be a float. Okay. And finally, I can take x to the power of y. And in this case, it's going to be 8. Okay. So those are very, very straightforward. Any questions so far? Okay. So now let's move on to functions. For your first homework, you have tons of functions to write. So let's look at small scale function. Yes. What did that mean?
Like with the x, y, you could put z in there as well. How would you just do it? You know, how would you like integrate that within the, could you?
I haven't even tried. Like I said, I'm not a big fan of this shorthand thing, but let's try it. So you want to do x equal to x times, let's not do power. Let's just do multiplication, right? Let's see if we can do it. Let's first try it. Make sure. Okay, so now I want to do I can do this, right? But I think what you are, I think this is fine, right? This is totally fine. But I think what you, yeah, see, this is a tricky thing. I don't know if I never tried this. Actually, I don't know. Yeah, so you can do it once. I'm not sure if you can do it multiple times.
I'm guessing we're not going to be like doing that, right?
Let's try it. I mean, it's going to complain, most likely. Oh, no, it doesn't. Oh, no, actually, what this does, this is actually saying that I'm doing x to the power of y times z. Actually, let's be careful. Y times z is 15. So is it 2 to the power 15 or this? Let's make sure. Yes. Okay. All right, function recap. Okay, so let's talk about simple function. Is that it has a name, right? Think about a function as, in some cases, you can think about as a box. You have input to the box and you have output to that box. And it has a name. It takes input, which is defined by this parameter. And it sometimes return a value, sometimes it doesn't. And indentation, which is basically this kind of space right here, is what distinguishes the main body of the function from the surrounding code. This is another interesting thing about Python, is indentation really matter. Some other programming language, no matter how much you indent, you are going to be okay. But for Python, if you're not careful, what you tend to be inside the function will be outside the function and things will be screwed up. So in this particular case, my entire function is this, which is simple, does addition. It takes two variable x and y. It computes a variable result, which is equal to x plus y, and then returns it. And then, for example, if I just call this function add 1 and 9, what's the result going to be? 10, right? Because it calls a function. Now, there is the interesting things about functions, because there are variables that is defined internal to the function, and then there's variables that is external to the functions. So this is what we call sort of the scope, whether it's within or within the function, without function. For example, in this particular case, right? If I do, oops, that's not what I want to do. If I call this function scope test, it's going to do function scope. And inside the function, I have a variable that is only readable in here, and I print this. But if I actually do it outside, see right here, what's going to happen? Nope, sorry, my keyboard is actually going to complain, right? It's going to say name function scope is not defined. The reason why is, one of this variable is only defined as something internal to this box, and it's not visible to the outside. Okay. Now, there's occasionally when you have functions, it has so many inputs, and sometimes you just don't want to specify all of them. This is situations where you just want to specify some default value. So if those parameters were not provided, it will just use the default value. So for example, in this case, I have just a simple function that takes 3 input A, B, and C. And the idea is in the definition, I'm going to specify its value, which means that if I don't provide it, it's going to take this default value. And in this case, the default value is basically empty string. So for example, if I call it firstly just by the first variable, it just says my first variable is A. So it's going to print A, okay? Now, if I also just specify B is equal to sort of like string B, then it's going to treat A to be empty and C to be empty. So it's going to print just B. And now the third one is to say, well, you also don't have to specify those variables in order. In this case, I know that in my original definition, A is B and A come before B, come before C. Now I can sort of say for C variable, I want to specify to be CC, and for A variable is AAA. But when I print it, it's going to print A, and then empty string, and then C. Okay. Let's do one more. So what about if I just print variable like this? What's going to happen? Right, it's just going to be an empty line because, like there's nothing specified. Okay. Now, the other awesome thing about Python is that it can take arbitrary length arguments. So when you put star into this variable, this is just to say I can have, 2, 3, 4, 5, many number of input. In this particular case, for example, I have this function called variable argument, which means I can take any number of input. And if I specify, in this case, 3 or 4 strings, what's going to happen? It's going to treat it to say, okay, it's taking 4 input, and I'm just going to have the output. Okay. All right. Now, those are simple functions. And then before we start describing more complicated function, let's talk about if, then, else, and else, if. So those are conditional statement, essentially saying that, if certain condition is satisfied, I'm going to do one type of operation. Otherwise, I'm going to do other type of operations. That is if and else. So the first example, which is very typical, is to check if a number is odd. So if you think about from, I don't know, discrete math, right? How do you check if a number is even, an integer is even or odd? What is sort of the procedure you do? Yeah, divided by 2, right? If it has no zero remainder, it's even, otherwise it's odd. So that's exactly what this code does. It says, well, because the function is checking if it's odd, so if I sort of take the remainder divided by 2, if the remainder is 1, then I say, well, I also do a little bit typecasting. I convert it to a string to say, okay, this number is in fact an odd number. Otherwise, which means it's not equal to 1, I'm going to say this is an even number, okay? So if I input 144, what is it going to say? If I call is odd 144, it's going to say it's an even number, and the second one is an odd number. Oops. Okay. What about 144.5 or 6? Okay. So again, be a little bit careful about how this remainder operation is happening. What about 11.55? Oops, sorry, my keyboard. See, this is not your intended answer, right? So in a way, this is already an indication that, okay, in general, this is a reasonable function, but you have not protected your function in the way of assuming the input is just integer, right? Because the quotient operation is actually not constrained to integer. So what do you do? Yeah.
Would you put in at the beginning of X inside is odd function?
Yes, you can do a typecasting, right? If you do a typecasting, it's kind of, well, it's not, depends on what your end goal is, right? If it comes in and you can see, well, if it's actually integer, if it's not an integer, you can also say, okay, I'm going to convert it to an integer and progress with what I'm going to do. Depends on your objective. If you really want to say, well, if somebody does not give me an integer, then I want to throw an error message. It's like, well, my input is not an integer, right? But of course, to guarantee your code run without any issue or produce the expected result, you can take those two routes, either typecasting to guarantee it's always an integer, or you can throw a message, a warning message to say my input is not integer, okay? Now, there's minor things you can put parentheses or not in this condition, and it does the same thing. It's just more of your comfort level. Okay. Oh, sorry. Go ahead. Question?
Well, I noticed you had a bunch of functions, right? There's no return statement. You don't need return statement.
You don't need return statement, right? So, like I said, you can have a function that takes some input, do something, and be done with it, or it has an input and has an output. Okay. So what is this going to do? If true and false or true, print true. Is it going to print true? Yeah. So in fact, true and false is false, but then false or true is true. So it's going to print. Okay. But if I do this, what's going to happen? Oops, sorry, my keyboard. It's not going to do anything because this argument here is evaluate false. So when you think about the conditional statement is that whenever something evaluated true, then you do what's after it. Otherwise, you're going to do something else. So in some sense that there is an evaluation of this thing being true in order to proceed. And then of course, the question is, what are the false statements? Well, a Boolean variable false is false, of course. but a value of 0 is also considered false. An empty list, which we're going to see very soon, is considered false. An empty string is considered false, and a value of none is considered false. Okay. Everything else is considered true. So for example, if I have this if then else statement, which one is going to be printed? 0 is false because 0 is evaluated false. So if I do it like this, see the second statement is printed. Now the second one, right? I have a non-defined variable, which is a value of none. And then it says not of this, which is true, then the second line is printed, right? Same thing with, remember, empty list is considered false. So not false is true. So of course, this is also printed right here. And finally, empty string is considered false, but not empty string is considered true. So it's also printed. Okay. Now you have what we have gone through is if and else. But you can also have those kind of nested if then else kind of situation. And that's what you called, how to pronounce it? Everybody have a different pronunciation, elif, or it's basically else if, right? So this is a slightly more complicated function right now, is that it takes a number x and to check what is the smallest factor, okay? So what happened is that I take the input x and I take the 2 and look at the remainder. If, remember it says not this. What does that mean? Is that if this is an even number, which means its remainder over 2 is empty, it's 0, sorry. And then not 0 is true, which means that it's actually divisible by 2. Then you say 2 is a factor, okay? And of course, if 2 isn't, you go to the next. So this symbol here means else if. So if it's not satisfied that, it has 0 remainder for divided by 2, then I'm going to say, well, let's divide it by 3, okay? So again, if it's remainder divided by 3 is 0, that means it's divisible by 3. Then I go say 3 is a factor. And then I say, else, I'm going to say, well, it's not divisible by 2, it's not divisible by 3. Now, either 2 or 3 is this factor, okay? So in this particular case, 4 is going to go into the first if statement and print, and then that's done. Because when you have this if and else kind of thing, you only go into one of those branch. And once you execute the branch, you come out of the if statement, and then that's the end of this function, right? Same thing with 9. When you find 9 just goes into, well, it's first check. Well, this is not satisfied. It goes to the second branch. It is satisfied. Then it's printed 3 to be the factor. And then 12, it's divisible by 2, so it's only the first branch. And then finally 13, it's not satisfied the first condition, not satisfied the second condition. It goes to the else branch and says, well, it's not divisible by 2 nor 3. Okay. All right. So very specifically, it basically means that you only goes into one branch or another. And you can also do it in a slightly different way. And then this is not equivalent, is that, well, in this case, I'm going to check sort of sequentially the if statement. Is it divisible by 2? Is it divisible by 3? Is it divisible by neither? Okay. So in this particular case, no, I actually want to execute this one, right? And then you can see what the end results looks like. I want to give everybody a 5 minutes break. And also, if I forgot, just remind me. We'll come back at 4:25. Okay.
It was.
All right, so there's a question for this is smallest vector function. How can we make it so we can only send it integer input? You can again do typecasting, right? So you can say that, you know, if it's input and if you check if it's not integer, if it's not integer, you throw a warning message, or you can just force it to do a typecasting. Yeah, the K95 is better than the regular one. Yeah.
So you want to know what kind of elements. Yeah,
All right, let's resume. All right, so what we have dealt with so far are what's called basic data types, are things like booleans, numbers, strings. What we're going to move in towards are the first compound data type, which is called lists. And then the closest, well, list is basically a collection of items. And if you know some other programming language, the closest thing to it are things like arrays. But in some other languages, arrays and lists are not the same thing. So in this case, the lists are usually created with square bracket, okay? And they can be accessed with an index. So in that case, it's very similar to an array because you can start talking about, well, give me the first, the zeros, the first, the second item. The most important part is that the list start with indexing 0, okay? So for example, in this case, I have, well, a list consists of members from Beatles. In this, and also I do 0 dash, 1 dash, 2 dash to emphasize their ordering. And now if I actually print the entire array like this, it's going to say, okay, it's an array, left bracket, right bracket, and then here are the element in the array. But now I can actually print specific element. Remember, it starts from 0. So the 0th element is actually what from English language is the first element. So in this case, if I say Beatles, square bracket 0 is going to print 0 dash poor, and 2 is going to be 0, 1, 2, and it's going to be George. Okay, so let's do a little bit changes. I've been watching Expanse a lot, so let's do Expanse characters. Let's say James Holden, Bobby. What are the other characters? Oh gosh, it's hard to spell. Spell it for me. Naomi. Yep. Okay, let's just do 3, okay? All right. Now, what's going to happen is that what's going to be the first element? What is going to be Beatles 0? James, what about Beatles 1? Bobby, okay? So I'm not changing the variable names, I'm just overloading them. All right, that's what you have. Okay, now you can look at, oh, now I have to do, sorry, I have to change it back. Oh, well, let's just work with it. Okay, so I have, let me just make sure, give me another one, Alice, which died, so it's fine. Let's do it. Okay, so now if we're going to print from the back of the list, okay? -1, -2, it says from the back, what is the last one and the second last one, okay? And that is quite different from some other languages, okay? Now, if we are out of bound, remember I only have 4 elements. So if I index 4, I'm trying to access the 5th element. And this is going to say index error, okay? List index out of range, okay? Now, again, this is a sort of non-conventional thing. You can create or pre-initialize an array of a certain size. In this particular case, when I do bracket 0 times 10, I'm creating an array of 10 elements. Each of them is a value 0. Right, that's what you have. Again, it's sort of like shorthand scripting. Now you can talk about how to access the array. You can specify starting, ending index. And remember, whoops, shouldn't be clicking on it, but that's okay. Remember when you do start and end, it's always indexing until end -1. And when you start, it starts from the starting index until the very end, and end is starting from the beginning to ending index. And if I just do column, it's just a copy of the whole thing. Okay, so you can also do step size, meaning that I'm going to start with some starting thing with an ending index with a step size, but not passing the end index. So you can kind of jump, the first element, the third element, the 5th element with a step size of 2. Okay, so and also there is, when we talk about this kind of operations, those are called slicing operations. The original array is untouched. You are simply query what's in there, okay? So in this case, if I just look at, well, give me starting, which is at the beginning, up to 2 - 1. So I'm going to give you element at index 0, index 1, which is James and Bobby, okay? Now, the next one is to say I'm going to slicing from 2 until the end. if you remember 2, index 2 is 0, 1, 2, index 2 is Naomi. So I'll start with Naomi until the very end. Similarly, in this particular case, I'm just going to provide a copy of the entire list. Now, if I were to do slicing, again, I'm out of range. It's going to give me an empty list. Okay. The interesting thing is that if you actually have a string, it's very much so you can also do slicing with the string. So it's almost like a list, but in this case, I'm slicing the string based on the characters. So if I have, you know, Paul, if I say I'm going to look at the characters, that is from 0 up until 4 minus 1, which is 3. So I'm looking at the first 4 characters, and that's what's going to return is going to be the string Paul. You can also, well, this is a joke over Beatles once they get married. You can also change the element in a list. Well, now I'm just changing my expanse one. I'm changing a second element, which is index 1, to be a new string. Okay, so you kind of can change the values. But you can't do the changing of character within a string, okay? Even though you can slice a string, but you cannot change a character in a string. So that's the difference between the string and list, right? So that is what we call immutable versus the list is mutable. Similar things like append, you know, you can add extra. Of course, this works better with the Beetle example, but you can kind of take the list, add extra element to the end of the list using append. You can concatenate, which is, again, we've seen this before, which is using plus operation. So in this particular case, I'm going to take all the strings in the Beetle versus all the strings in the Zeppelin, and then create a new list. Of course, I mutated. I changed the original list, but now I'm just taking 2 lists, put them together. You can get the length of a list. So for example, Zeppelin, it says 4. It means it has 4 characters in the Zeppelin list right here. It says it has 4 elements. So that is the length operation. You can also create a list of lists. For example, in this case, what I did is that Beatles is a list by itself. Zeppelin is a list by itself. I'm going to concat them together, create a new list, where in this particular case, this list, okay, so let me ask you a question. What is the length of this list I just created? Exactly, right? So it's a list of lists. So it has 2 elements, but each element is a list, okay? What about the length of, well, actually, no, I want to do length of this. Five. Okay, I have the 4 element from our original thing. Remember, at some point I concatenated someone. So the length of the first element of my list, which is a list by itself, that list is of length 5. All right, let's move on. Okay, the flexibility of Python is that you can also put different types in the same list, basically treating it as a collection, right? It's like you have a bag, you put a bunch of apples, bananas, fruit in the bag, but then sometimes you throw, like, I don't know, a laptop in the bag. Now, in general, this is not good practice. Okay, it's not really recommended to do it, even though it's doable, right? In this particular case, I created a list that has my list of lists, right? So this is an element, you know, it has multiple elements. The first element is a list. The second element is a list. The third element is an integer. The fourth one is a float. The last one, there's another integer, and then there's a string. Okay, so in a way that the list is a very flexible kind of structure where it's a flexible type. You can put anything in there, but it's not recommended because oftentimes you want to do operations over element in that list. And if it's mixed types, you're going to encounter problems, right? Especially when those operations you're doing is hidden somewhere in your program. And later on, when you're operating on that list object, you actually forgot that is a mixed type. So so, okay. Now this is a place where NumPy package also have list, okay? So when you use NumPy, it's a very commonly used package. It has a lot of data structure operations, especially for scientific computing, and with a lot of good performances. So if you want to have efficient algorithms, you can use NumPy package. NumPy also provide things like array, right? And in this particular case, you can do the similar thing as you're doing with the native list type, similar operations you can do. In this case, first of all, in order to use NumPy package, I need to import it. And this is a very common way. I import it, but I kind of rename it to be a shorthand so I can use it later. And once I import it, I can use the type that is defined by the NumPy package. In this case, it has an array type. So now I'm creating an array that contains integer 1, 2, 3, 4, 5. Now, again, I can do this sort of indexing and slicing as before. For example, if I'm going to return my first element, I was not doing anything. Yes, okay. So if I'm doing the first element, is going to be the second, really, index 0, index 1. Index 1 is number 2. -1 is the last element, which is 5. Index be from 1 to 3, then it's going to be 2 and 3. The most important part, and then this is what sort of restriction to NumPy, when you start playing with integers in NumPy, the type is now int64, which means that the integer now has upper bound. If you go beyond that, you're going to have an overflow. So when you're dealing with integer in the native type, you can have arbitrary large integers, but when you're dealing with integers that's coming from NumPy array, you have sort of the upper bound in terms of size, okay? NumPy has a lot of functionalities, and we'll see them as we go along with the class. It's okay to do hybrid in the Python lists, but not okay to do in the NumPy array. In fact, what NumPy array is going to try to do when you have a mixed type, it's going to try to typecast to the most common type. In this particular case, I have a mixture of integer and string. And what NumPy is going to do is string is more sort of more general, so it's going to convert each of integer to a string. That's what's going to happen. All right, so if you see what's happening is that I'm going to print what's in my, did you see the major difference is that each of those integers from the NumPy array is now converted to a string. Okay, and then if I'm asking what is the type of my particular element, like say this element, what is this particular type? It's going to say it's a string. It's no longer an integer because it did the type conversion inside. Okay. Now let's move on to loops. And this is fun. And then hopefully I will get to recursion. So loops are essentially you have operations. You want to repeat it many times and you don't want to keep writing the same operation. So that's where loops comes from. And loops usually have, again, a condition. And once that condition is satisfied, you continue executing the loop until it's unsatisfied, then you get out of the loop. So let's start from the first one. While loop. While loop execute as long as the condition right after the while statement hold. So I start with the initial integer a is equal to 1. It says as long as my integer is smaller or equal to 100, I'm going to print this integer and I'm going to add 1 to it. Okay. So can someone tell me what this function do? Yeah. All right, one at a time. Somebody? Yeah, go ahead.
13 here is from 1 to 100.
1 to 100, exactly. Okay. What about I do this? 99, right? Because it's always, each time it's executed, go back to the while condition. Is it smaller than 100? 99 is it smaller than 100? Great, I'm going to print it. But when it's reach 100, 100 is no longer smaller than 100. So it's come out of the while loop. So it's terminate. One of the biggest problem with any time we're using a loop is you want to make sure the condition that get out of the loop is sometimes going to be satisfied. Otherwise, your program is going to run forever until it runs out of memory. Okay. So, right. So this is a simple example of a while loop that never terminate, right? Because it's always true. While true, just keep saying it's stuck. It's going to, I'm not going to run it on my browser, but this is what's going to happen. Yes.
I'm curious about the n equals like comma thing. And that, like, is there something you can do like at the beginning and like, or how, like, what are the different ways of packing something on, like formatting when you're?
Oh, again, very importantly, is this indentation. Right? Oh, this here is part of the syntax.
Oh, like within the print statement, like the n equals and the quotation marks.
Oh, yes, right. So what happened actually, yeah, this is sort of like a little bit imperfect if you're a little bit like OCD like me, you know, you print it at the very end, you're like, oh, there's an extra, you know, thing. You can do a if statement in here. Is it what you're going after? You want to get rid of?
Oh, no,
The last
I
one?
was just curious what it was, and I'm curious if you're
Oh.
going to do it at the beginning too. Like if you wanted to add like a dollar sign onto like some amount of money or something. If you remove the n equals, it prints them all on a new line. And it looks kind of ugly.
Oh. So say at the end, insert a comma and a space.
Oh, yeah. Okay, that was the question. Sorry. I thought you were asking something fancier. Okay. All right. Yes. Yes. This is trying to not to have my program goes like 100 lines, right?
Is there like an equivalent though for putting something at the beginning?
What do you mean by that?
Like if you wanted to like if those were dollar amounts or something, you wanted to add like a dollar sign at the beginning of each of them before printing it? Is there like a way to do the same thing?
Let's see. Let's see. Oh. Yep. Syntax arrow. What did I do? Let me just try something else. Yep. Let's do this. Okay. And I think dollar sign is fine. Like this. This is fine. Let's try it. Yep. This is totally fine. So I need to do a little bit typecasting, just, you know, that's it. Yeah. Okay. Now, yeah. So I was trying not to do, yeah. So I did, this is just a concatenation, right? Yeah. Now, next thing, if I have something inside that I can try to force me to get out of the loop just using break. So in this case, if I don't have this last two lines, it's just going to continue executing, right? It's going to print because it's always satisfied. But now I can put inside, you know, if the number is bigger than 100, it's going to break. That means it's going to come out of the current loop. So again, it's going to achieve the same result as before. You know, I'm going to print from 1 to 100 because whenever it's reached 100, it's no longer, oh, sorry, if it's reached 101, it's bigger than 100, then it's come out of it, okay? Now, there's also, break is coming out of the loop. Continue is to say, well, I'm going to, goes back to the start of the loop in the next cycle and continue executing. So in this particular case, is that I'm going to start with a number 0, as long as it's less than 100, I'm going to keep increasing it. But now what's going to happen is to say, if this is divisible by 3, I'm going to print I'm going to print it. And then continue, meaning that I am going to go to the beginning of this loop. So what this does is that it's going to print, otherwise it's going to print the sort of the number itself. So what it does is to say, I'm going to print numbers, but whenever something is divisible by 3, I'm going to put a bracket and I'm just going to keep going. Okay, so what is happening is that when I say continue, say for example, 3 comes in, I'm going to put a left and right bracket to this number. And then when I say continue, I don't execute the last line because I don't want to print this number twice. Then I'm just going to go to the beginning. Okay, so that's what you see. 1 and 2 is not divisible by 3, so it goes straight to the last line of the loop. When it's 3, it goes to the if statement and printed with a bracket, and then continue goes to the beginning of the loop. So each number is only printed once. Yes,
What is the F?
I was going to say that. That was you're 2 seconds ahead of me. So what this F is actually sort of like a shorthand of sort of taking the input and think about it as a very, very shorthand function. It takes the input and it's actually concatenated with the bracket. Right, so that's what it does is it takes input A, oops, and it put the bracket surrounding it and treating it as a function. Okay. So this is what's called a format string. So format string is essentially you put an F before the quotation, and then the variable is in the sort of curly bracket. So again, I'm going back to expense, that in this particular case, you know, my formatting is I'm going to take my input, which is my name variable, and I'm going to return a string that has sort of my name is concatenated to it. So if I execute this, this is going to say my name is James Holden. All right, so yeah, I mean, Python is actually quite powerful when it comes to manipulation of strings and shorthands once you get used to it. Now, that's a loop, for loop. Okay, for loop is for some variable in a sequence, I'm going to do something. So in this particular case, well, think about what this for loop does. It's try to iterate over a collection of things, over a sequence. So Zeppelin is a sort of a list of band member, and it says for each member, I'm going to print its name. So that's going to print the 4 band name. I don't know why I have a double jump. Maybe I have done something earlier. Okay. Now you can do arbitrary slice. Let's say my Zeppelin, now I have those 4 names, but I only want to print, you know, anything starting from index 0 up until index 2 minus 1, which is index 1. So it's only the first 2 items. Then it's going to be the first 2 names. Okay. You can also nesting, right? So remember my bands is this list of list. So if I do a band in, because I have nested list, of course I modified a little bit, so it's kind of weird. I have each element in this nested list. I'm first going to print band member, and then for each element in this list, which is by itself a list, I'm going to print its element. And that's what you get. Okay, so this is sort of the first element of the list. This is the second element of the list, which by itself is a list, and I'm going to go through the elements in those lists. Okay. Now you can also, what you want to do is to iterate through sequence of numbers. You can specify range. So when I say range 5, this is just say that this is sort of a sequence of numbers that go from 0 until 5. So now this is an interesting thing is that for each number in the range 10, what you're going to do is that I'm going to print this number. So I'm generating a number from range from 0 to up to 10, but it's actually only including 9. So again, this is a very similar indexing kind of situation. You just say, I'm going to print the numbers from 0 to 9. So again, you are iterating through a collection of a sequence of things. But you can also create a new list using the range. In this particular case, you know my range is 5. So from 0 to 4, I create it into a list by specify the typecasting into a list. Okay, now this is something that you can work with. You can also, same thing with the range, which is very similar to how you're playing with a list. You can do start, end, and gap. So in this case, if I do start at 0, end at 10 with 2 gap of 2, then this list you created is starting from 0 at 2 and up until 8. Remember, I'm not including the element 10. So because this range is up to 9. Okay. You can also do, you can also do things like, negative integer. There's no reason why you can't do a range of negative integers. So this particular case, you start from 0 and you have a gap of -3 up until -20. So you created a list of negative integer of this gap. All right, so first time I'm going to talk about recursion. How many of you has done recursion before? Okay, so it would take a little while to get used to recursion, but we'll try it. And then as we go along, you might see some other examples. Okay, so this is really going to drive you nuts. Okay, so recursion is a function that calls itself until it does not. Okay, so let's start with first simple example of recursion. You start with, so I'm going to call this function. It's going to say, well, I'm going to provide 2 input to this function. It has a current number and it's a limit. So when you go into the function, it's going to first print the current number. And if the current number is smaller than the limit, I'm going to call it again by increasing my current number by 1. Okay. What do you expect the results going to be if I call it 0, 10? It's going to keep going, increasing until the if statement is no longer satisfied. So it's going to print up until 10. So this always takes a little bit getting used to. One of the best way to understand recursion is actually have a piece of paper next to it, and you go through one step at a time as how you call this function. So when you first go in, you call 0, 10. So when I call 0, 10, it's going into the function for the first time. So depth number 1. It's going to print 0. Okay. Now 0 has been printed. I'm going to go into the if statement. Is 0 smaller than 10? Yes. So I'm now going to call this function again. I'm going to call this function again, except I'm increasing the current number by 1. So now I'm calling the function as print number 1 and 10. Okay. So in some sense, this 0 is printed the first time you enter the function. Now you enter the function for the second time. That's where recursion comes in. When you recurse the function, you print. Now you're calling print number 1 and 10. So when you call that again, the first line is print 1. And it's going to if statement. Is 1 smaller than 10? Yes. So I'm going to increase 1 by 2. And now I'm calling the function itself the third time. Okay. And it's going to print 2. And I keep going until at some point, I'm going to say, well, is 9 smaller than 10? Yes. So I'm going to call the function print 10, 10. When I call print 10, 10, it's going to print 10. And then it's going to go into the if statement. Is 10 smaller than 10? Nope. That's when the recursion terminates. Okay. So the most easy mistake you make when you do a recursion is when the condition in your recursion never terminates. So again, you go into this sort of infinite calling itself, and there's no stopping. So make sure your stopping criteria is met in your coding, and then you will be fine. Okay. Now, I can also do it reversely in the recursion. And again, this takes a little bit getting used to. Okay. The difference between this function in the previous function is a print statement. The previous function, this print number in the increasing order, is that I always print and then call the function, call itself. Okay. The difference is that now I'm going to check the if condition and then print. So what that means is actually going to keep going to call itself until it reached the condition it cannot go further. It came out of the if statement and kind of backtrack. Okay. So it's one way to think about it is that it's like you're digging a well. You only reach the bottom of the well, and when you come back, that's when the print statement is called. So again, you go in, you call it 0, 10. Well, 0 is smaller than 10. Good. So I'm going to call my function again. I'm going to say, well, I'm going to call 110. 110, 1 smaller than 10. Good. I'm going to call 210. Remember, throughout this whole process, nothing is printed. I'm just keep going deeper and deeper until I reach is 9 smaller than 10. Yes. So I'm going to print 1010. Now, the last part, when I say print 1010, 10 is not smaller than 10. That's where this if statement is not satisfied. I get out of this if statement. I'm going to print 10. Now, that is the deepest call of my recursion. Once that's done, I'm going to the previous version and then print 9, and then previous version and print 8. So this, again, takes a little bit getting used to. The best thing to do is having a piece of paper and just see what the program is doing, right? Because remember, while I'm going deeper at each level, for each level, there's an extra statement that I have not reached. So it's only reached after I get out of the last if statement. So that's why your list is printed in a reverse order. So you can do a little bit extra to just give a little bit more information of what is the depths you're going. That's exactly what I'm talking about. Thinking about it as a well, and you go deeper and deeper. You keep going deeper until you are at depth 10. And then you return at depth 10, return at depth 9, return at depth 8, return at depth 7. When you return at each step, that's when the print statement is happening. Okay. All right. Finally, you can return values in recursive functions, the recursive calls. So in this, again, you're using the formatting that we've seen before. So this is just to get, sometimes my hard key does not work as well. Oh yeah, sorry, I need to do this one. Yeah, so in this particular case, I can get sort of the, well, actually exactly why I didn't run, because I didn't call it. So if I run it from 0 to 10, again, you can actually think about, this is again a recursive call, except the recursive call is inside the result you are returning. Okay, so it's a little bit more compact coding, and what this does is actually returns a sequence of those numbers. Okay, so I'm actually running a little bit behind today. I don't have too much left. Oh yes, so if you don't mind, I'm just going to finish up really quick. The last bit we want to talk about is, there is this interesting thing called a list comprehension, which is basically transform and initialize an array. So for example, in this case, when I not specify this, which use this underscore, it's just to say any variable name, I don't really need it, but for anything in here, I'm going to initialize it to be 0. So what this does is to say, I'm going to put 0 to an array of 10 elements, and each one of them is going to be 0. And same thing here, I'm going to create an array of 10 elements, and each one of them is going to be the string John, right? So this is just an easy way to initialize and to set values. For example, in this particular case, I'm going to say, well, I have a range from 0 to 9, sorry, 0 to 9, And for each of the element, I'm just going to assign value from 0 to 9. And finally, the ones that you can use are, you can generate random number. This might be useful later. You can use the random package, and you can generate random numbers from the range. There, you can generate, in this case, each time I generate RAM, this is generating a random number from 0 to 1. Okay, but of course you can operate on it. You can say, well, I'm going to generate a random number, but then I'm going to multiply by 10. So now I'm generating a random number, but then I'm amplifying it by like 10 magnitude. That's it. Okay, so that's that. Thank you for your patience. We're 1 minute over time. There is exercise, group exercise. So you might want to do it, on your own. This is under lecture 3 exercises. Remember that we have a large number of exercises. You only need to submit 5 to Canvas. But the important thing is for you to do those exercises on your own or with your group friends, just to learn it together as material. Okay. Yes, you're first. Canvas. So Canvas, it's actually called activity. It says activity 1, 2, 3, 4, 5. So it's like each one of them is worth 1 point. So you just submit across the semester, you choose 5 of them to submit. It's really just for making sure you practice and get used to the code. Yeah. Yeah, it's not called exercise, it's called activity. Yeah. Question? Can you be louder? You want to ask questions? What is the question again? Oh yeah, let me stop the sharing.